Hi everyone. Good afternoon, guys. Very good afternoon, everyone. How are you all? Everyone, how are you? Hope you're all doing well. So, we'll be continuing our discussions on this quick revision sessions, right? That highway revision sessions we are doing now is an already, right? Highway revision sessions we are doing already. So, these revision sessions will be continuing as usual, you can say. Right. Audio clear or not clear? Here, somebody. It is streaming or it is not streaming? Is it streaming, everyone? Yeah, it is streaming very slowly, you can say. Yes, it is streaming now. Why? Yeah. Audio both are clear, everyone? Right. So this highway quick revision series will be having. So all of you, welcome to Unacademy. Let's crack it, right, everyone? Be ready to crack, you can say. Now, uh, what is the referral code you have to use, all of you? RP Civil is the referral code you have to use, right? Whenever you are subscribing to this plus and iconic courses, whatever it is, right? Is not? Now, so this is my profile. You can follow me at which, and what is the referral code you have to use? Right, RP Civil is the referral code you have to use, and you can recommend the same code to which one? These all your friends, juniors, and everybody also. Okay, right. Now coming to this. So these are all which one? Gate 2024 toppers. Those who got AIR 1 in from Unacademy, you can say. And now, so at present this unlock 2025 is back again, right? So what is it you can say? That unlock 2025 offer is back again. So what is that unlock 2025 offer? If you just observe, so you'll be getting that a plus a subscription, right? So you'll be getting which one? This plus a subscription for which one? This is 12,999 only, and this offer is valid up to which one? This May 18th, everyone, right? So this offer is valid up to which one? May 18th only. So hurry up, guys, right, before this offer gets expired, all of you. Right, what is it? A referral code you have to use always here. RP Civil is the referral code you have to use now. Yes. So here for 2025, 9 months subscription is at this 12,999, and 24 months subscription is at this 24,999, you can see. Okay. So what is the code you have to use? Right, RP Civil is the code you have to use, you can say. Okay. Right, so this is a new batch starting, all of you. Pratigya batch for this gate CE 2025 people aspirants. So this batch will be starting in Hindi, you can say, right? Geotechnical engineering by Abhishek Kumar and engineering mathematics by Gurupal sir will be starting, you can say, right? Don't miss this, all of you. New batch for this 2026 people will be starting with the same subjects, all of you. Okay, so those who are taking iconic subscription, they will be getting these printed books delivered within 15 days of your subscription to your home, right? Now coming to this, right, what is that part we have discussed in that last class? You can say that rigid payment part we were discussing now, if you just remember, right? So what is that part we were discussing in the previous class, which happened on this 8th May? So this is design of this flexible payment, that is CBR method gets over, and what is it you can say? The CBR method gets over, IRC method also over, fatigue life gets over, na? So no. So this fatigue life is depending upon which one? That NF is depending upon these things we have seen, is na? No. Here, this is lecture 21. So this is 246 point to 247 point will be going for, right? So this is also flexible payment, we can see now. 246 gets over. Next 247th point, if you just look at what is the 247th point, you can say fatigue gets over now. So that is next one is what? A rutting failure we have to talk about. What is that a rutting, if you just consider, anyone? What is that a rutting, if you consider, if you just observe, anyone? So rutting is nothing but your depression, na? So whenever these are your payment layers, if you just observe, These are the pavement layers, you can say, right? What is it, you can say? This is your vehicle. This is your vehicle, right? So here if you just observe it, these are the depressions will be getting, right? Longitudinal depressions if you are getting now, so then this is called as your rutting failure, right? When you can say this is your rutting failure, right, that is your 2 centimeter depression or this 20 millimeter depression occurs now, then it is called as your which one? This is a rutting failure, right? So just like that, if 2 millimeter depression occurs, right, can you call it as a rutting? No, we cannot call it as rutting if this 2 millimeter depression occurs, right? So rutting failure, when you can call it as, if 2 centimeter or this 20 millimeter depression occurs, right, then you can call it as this rutting failure if you just observe, right? Got it? Now here, what is it you can say? That same reliability criteria. So 10% of this road length. So that 10% of this road length uh, may be expected to have which one? It may be expected to have what you can say? It may be expected to have this 20 millimeter depression, right? So 20 millimeter or this 2 centimeter both are same na. If it is expected to have this 20 millimeter depression na, then you can say that it will be corresponding to this 90% reliability. So 90% reliability means what is it you can say? 90% of this road length is safe. Only how much road length is not safe? Only that 10% of this road length is not safe na. Only that 10% of this road length is not safe, you can say, right? That is what. So now here if we just observe 80% reliability rate, how can you define? When at 20% of this road length, right? What is it you can say? That at 20% of this road length, it may be expected to have which one? This is the same 20 millimeter depression na. Then you can call it as which one? This 80% reliability, right? Yeah, Pavan Kumar. Good afternoon. Then it is said to be having which one? This 80% reliability, right? So 20% of this road length is only subjected to failure, 80% reliability, and only 10% of this road length is subjected to failure, right? Then you can call it as which one? This 90% reliability, right? So 10% road only failed means 90% length of this road will not fail now. So you can say that 90% of the road length it will be safe or not? Obviously, yes, it will be safe. Obviously, you can say yes, now, isn't it? Right now, so here if we just observe, similarly, to have this kind of this failure, right, just like that, do we have this failure? No, na, we cannot have this kind of failure just like that, na, right? What is it we can have? There must be some number of standard axial repetitions we should have movement for this failure to happen, right? What is that you can say if you just observe? That is your rutting life. Rutting life, NF. So what is it, a rutting life if you just observe? Rutting life is nothing but your, it is the number of equivalent standard axial repetitions. Number of which one? It is the number of equivalent standard axial repetitions. What they will do? Required to cause which one? This is the number of standard axial repetitions required to cause what you can say? Required to cause this rutting failure. So whoever is causing this rutting failure, right, they will be taken as which one? This equivalent number of the standard axles, that is your rutting life, right? So and this NF is nothing but your so NR, okay? For fatigue it is NF, and for this rutting it will be which one? This NR, right? Number of repetitions required to corresponding to rutting failure, right? And what is that NR if you just observe? That NR depends on what? That NR depends on which one? You can say that NR depends on maximum vertical subgrade strain. Maximum vertical which one? It depends on this maximum vertical subgrade strain, epsilon V, right? Like that. Because here depression means it is supposed to resist this vertical one, or it is supposed to reduce this horizontal strain, you can say. it is supposed to reduce this vertical strain. When your bottom subgrade is capable of resisting this vertical strain, automatically that effect will not be there on the top layers, na? Isn't it? Like that. Okay, clear this one? Once clear, note down. Once want to tell me, we'll go on to the last point on this flexible pavement before entering into the rigid pavement. Note and tell me. Done? Right. 248 point gets over it. Now we'll be entering into which one? This is 249th point if you just right. Yes, na? 249th point you can say. So what is that 249th point if you just read here? How to manage BTech along with college, daily study plan, how to revise multiple subjects along with the current subject, and how to make short notes, right? Yeah. First, Mohit, you have to identify whenever you are going to college now, what are the free slots available? How many number of hours daily you can get, right? That you have to identify first. After identifying that, right, whatever the BTech subjects are going on now, it is better you prepare those subjects, right? If you are in a second year or first year now, whatever the subjects are going in your college now, those subjects you try to attend, try to prepare for the gate, right? So that what will happen in your university examination you can perform very well in that in those subjects, and gate preparation also will get over, you can say, is not the current subjects you have to do, right? Daily means how many number of hours you are having daily. You have to first write the list out, right? First morning this time to this time one slot is available, afternoon this time is available, evening this time is available, night time this time is available. If you are having this 3 slots, 4 slots now, 4 slots are available. Out of these 4 slots, 3 slots you go for this preparation of the subjects. You currently running semester subjects you go through, so that what will happen, both will be managed, right? Both will be managed, so that it will not be affecting your university examination, it will be useful for your gate examination also, right? Both that you can do it. Along with that, right, after that what we need to do, last slot will be there now. There you have to make the short notes and you have to revise the completed topics or completed subjects, right? So yesterday some topic is completed in all these 3 subjects, let us say. So for those make short notes, and day after tomorrow again, right? So whatever the topics completed now you do them, right? Once this subject is over, next subject when you are moving now, already completed subject also you try to revise it, just every day 10 minutes 15 minutes you have to keep for this already previously completed subject. So continuously you have to revise the previous subjects. Okay, yes, that is what, yes, understood now, Mohit? Right. So here what is that you can say, VDF values, right? What is that you can say, indicative values of this VDS. What is the meaning of this indicative VDF values, right? Indicative means what? Indicative VDF values as per which one? IRC. So that vehicle damage factor values if you just took, right? So it is based on which one, this initial traffic na? What is the symbol we have given for this initial traffic if you remember? What is the symbol we have given for this initial traffic? A is the symbol we have given for this initial traffic na? And P is the symbol we have given for this present traffic, you can say, na? There are 3 values are there, and based on these 3 values that VDF values will be given. You estimate. If you are unable to estimate enough, then you take these values directly. Okay, if you are unable to estimate, then you take these values directly. Okay, this is your terrain, whether you can say plain and rolling terrain. Next, what is it? Hilly terrain, right? Here, what is it you can say, that commercial, that 0 to which one, this 150 CVPD commercial vehicles per day, right? And what is the second one if you just observe, that is your 150 to which one, this 1500 CVPD, and it is greater than which one, this 1500 CVPD. Now, so what are these values we have to go for? This is your 1.5, 3.5 and 4.5. Is no 1.5, 3.5, 4.5, right? 1.5 plus 2, 3.5. So like that, right? So this is your 0.5, 1.5 and this is 2.5, right? Like that. These are the values of VDF. You can say as per IRC given standard values. Okay. Note this and tell me. Then we'll enter into this rigid payment. Before that, right, first we'll see what is the chapter number we have written for this rigid payment. You can say this is rigid payment, sorry, flexible payment, na? Chapter, okay, chapter number is not there. Okay, we'll write, no problem. Once this entire one is over, na, I'll be sharing this PDF. Okay, don't worry. Once this entire quick revision is over, na, entire revision is over, I'll be sharing the PDF after that. Okay, got it? Yes, yes, but after this entire discussions are over, I'll be going for that. Okay, after completing the topics only. Right. Note this and tell me. Note this values and tell me. Done, everyone? Noted this? Right. When we'll over this one, it is already running na. Rigid payment we are starting na. After rigid payment, which one is left? Traffic is left, right? So then automatically what happens, right? Once the traffic is over, this is also over, na. Son. No. Here next chapter will be which one? This is a rigid payment, you can see. Okay. Next chapter is what? Rigid payment if you just that is your 249th point na, right? So shall we go on to this 250th point? Rigid payment. So rigid payment, some 2 classes, 3 classes it will take. After that, traffic engineering, some 4 or 5 classes, right? With that, it will be over. Okay. Right. Done. This is done. No. So that is your 250th point. What is the design life for this rigid payment? You can say. So we need to design this flexible payment as well as this rigid payment for the same amount of time, or we should design it for this different amounts of time. We should design it for this different amounts of this time, na, son, obviously. So that design life will be taken as which one? Whenever there are high volume roads. What is the meaning of this high volume roads? Tell me. High volume roads, the design life is taken as your 30 years, and low volume roads, right? Low volume roads, they will be taken as which one? This is 20 years if you just observe, right? Is now here in case of your flexible payment, right, what was the standard axle? You can say single axle dual wheel assembly only was taken as the standard axle, na? Here also what is it? You can say single axle dual wheel only will be taking it or not? But do we take the same load, or we'll take a different load value if you just observe? Do we take the same load value, or we'll be taking the different load value if you just observe? We'll be taking that different load value, na? So no, we'll be taking the same load value or different load value? Different load value will be taking, right? But axle type will be same only, right? So what is that standard axle if you just say? What is that standard axle if you just observe? That standard axle will be which one? It is your single axle. It is a single axle with what conditions? Tell me. Dual wheel assembly. Now, what is that standard axial load we have to take it? If you just observe, what is that standard axial load we have to take it? Tell me. Same single axle with this dual wheel assembly only, right? Do you remember that single axle with this dual wheel assembly? So in the front view, if you just observe, right, left side of this axle two wheels are there, right side of this axle two wheels are there. This is your LS standard axle load, na? What is the standard axle load value? Tell me. It will be taken as your which one? This is 100 kilonewton, right? Or you can also write it as which one? This is 10.2 tons. Or you can also write it as which one? This is 10,200 kg, na? Like that we have to take it, right? No. So what are these other axial loads if we just observe? So instead of this one, you wanted to use other axles as the reference one, right? So do we need to use the same load or we have to use this different load? We have to use the different loads, na? Yes or no? What are these other axial loads if we just observe? Other axial loads, right? What is it? You can say the first and foremost one. Other axial loads are which one? This first and foremost one is what? Maximum single axial load. Maximum single axial load with what conditions? Tell me. With a single wheel on either side. Whenever it is at a single wheel on this either side, na, right, how much it is given? That is your 100 kilonewton, right? So with what conditions you consider it? With the dual wheel on this either side also, what is it we have to take it? That is the same 100 kilonewton only, na? 100 kilonewton only, right? So now what is the second one if you just observe? Maximum tandem axial load. So what is it you can say? Maximum which one? Tandem axial load, right? What is the maximum tandem axial load we have to select? So that is also for this dual wheel assembly only 186 kilonewton, right? And what is that next one if you just observe? Maximum tridem axial load, na? What is the maximum tridem axial load if you just observe? That is your, there it was 224, here it is 235 kilonewton, right? So compared to your flexible pavement, same axial conditions are there, but will be taking higher load for reference or will be taking lesser load for this reference, you can say. Will be taking which one? This is a higher load for reference compared to the flexible pavement, na? Yes or no? Like that. Okay, now this and tell me. Done? Everyone done? Others are done? Shall we move to the next? 253 point. 253 point, right? What is the cumulative standard axial repetitions if you just observe? The same cumulative standard axial repetitions will be same, na? So no, 365 into that A into, what is it you can say? 365 into that A into 1 plus R power n minus 1 divided by which one? This R into, what is it you can say? That is your VDF, right? Into, what is it you can say? LDF into, what is it you can say? That is your LSF, you can say, right? So now what is it? The rigidity factor will be taken as your contact pressure by this tire pressure, is not that vehicle damage factor. How to get that, right? The equations for this vehicle damage factor and this lane distribution factor value, right? What is it you can say? Equivalent single wheel load equivalent single wheel load, right? And equivalent axial load factor or this equivalency factor, right? All will be same as that of which one you consider it? All will be same as that of which one? This is flexible pavement only, na? So there is no difference, right? Do you need to write them again or no need to write? Same as flexible pavement only, na? Obviously. Same as which one? This is flexible pavement, you can say, right? It's not same as flexible pavement, you can say just right, isn't it? Here, so next one, other factors, right? Apart from this, some extra factors also there, right? What is that? You can say radius of this relative stiffness. What is that radius of this relative stiffness, right? Anyone having idea? Radius of this relative stiffness. What is the symbol we are using and what is the formula? Anyone remember? Radius of relative stiffness, right? L is the symbol we are having, right? That L will be equal to, what is that? You can say L will be equal to what? EH cube by, what is it? 12k into 1 minus mu square whole power, how much you can say? Whole power, how much you can say? Right? That is your 1 by 4, right? Whole power, how much it comes to be? That is your 1 by 4, right? What is that mu value? If you just observe, where that mu is nothing but your Poisson's ratio, na? Where mu is nothing but your Poisson's ratio, and what is that h? You can say h is your slab thickness, na? H is your slab thickness, right? What is the K value? You can say it is your modulus of subgrade reaction, na? Yes, correct, right? Modulus of this subgrade reaction or not? Yes. K is modulus of subgrade reaction or this is stiffness of this soil, na? Okay, Pavan. And what is another one? You can say E, you can say, if you just observe, that is your modulus of elasticity of this concrete, na? Modulus of elasticity of which one? Concrete. Modulus of elasticity of which one? This is concrete, you can say, right? And now what is that? You can say that is your 255. If you just observe, you never forget this formula. Okay, yeah, yes, yes, it came in get examination also. Yes. Now what is another one? If you just observe, it is your equivalent radius of this, sorry, resisting section, not relative stiffness. Equivalent radius of which one? This resisting section, right? Okay. How can you get this equivalent radius of this resisting section, and what is the formula? What is the symbol we are giving for this? That small b is the symbol we are giving now. So what is that small b? You can say under root 1.6 a square plus this h square minus which one? 0.675 times this h. When we have to go for, if that a is lesser than what? A is lesser than this 1.724 h, right? So and that b will be taken is equal to that a, na? When we have to take that, if that a is greater than or equal to that 1.724 h, right? Like that. So in the diagram I will be showing what is that B, what is that L, what is that A. A is the radius of contact area, na? Yes or no? We are mentioning that radius of contact area since long time. Right. Jot this and tell me. Jot this and tell me. Done? Supriya also done? Okay. So you are getting sleep. Right. Afternoon class, it is very, 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 very difficult, you can say then. Right. Okay. That is your which one? This 255, na? Okay. So this is your 256th one, you can say. And here if we just consider all of you, remaining 30% you have to keep empty, right? Now here let us say this is your payment. If you just observe, if you are eating 70%, you are getting sleep, means if you are taking 100%, what is the situation, tell me? Okay, this is your H, you can say. Right, that is your H, right? And now what is that? If you just that is your front view, na, right? Okay, this is your payment in the plan. So what are the two dimensions will be having for these, right? So this is your Ly, right? What is the Ly? You can say Ly is your width of this panel, na? This Ly is your width of this panel, you can say. And what is this? You consider it, that is your Lx. You consider it, Lx is nothing but your length of this panel, na? Lx is nothing but your length of this panel, if you just right. And whenever there is a load applied, right, which type of load applied? If you just observe that a wheel load will be applied onto this, na? That a wheel load P will be applied onto this or not? Now whenever that wheel load is applied, right, what is that shape of this wheel load area we have to consider? Originally it was rectangular curved, but we are taking it as which one? This is circular, na? Equivalent circular we are taking it, or not? Obviously yes. So now tell me, what is that radius of this load contact area? Small a is the radius of this load contact area. Yes, na? Now whenever load is applied like this, right, it will be subjected to this deflection in this manner, na? Now load is in this circular shape, so therefore deflected shape also will be considered as this circular only, na? Definitely. So the radius of that deflected area will be taken as your L, radius of relative stiffness, right? Why? That radius of relative stiffness L value is there, na? We are taking it as L, deflected area radius, right? Why? Because it is the area over which stiffness is required or not? It is the area over which stiffness is required. Why? Because wherever deflections are there, there only you need stiffness. That's not. Wherever deflections are there, there only you need which one? This is stiffness, you can say. So it is the radius of this deflected area. Yes, load applied over the small area, chota much area, but this much area is affected, right? Obviously, isn't it? And now tell me, some area will be resisting, na? Is that no? So this is the loaded area, green color one. That red color one is which one? This deflected area. And which portion of this member will be resisting? You can say this portion of this member will be resisting, na? That resisting area radius will be how much? You can say that is your B, na? Resisting area radius will be how much? You can say that is your B, if you just right. Is that clear? Right, that is what you are having. Now tell me, what are the different stresses in this rigid pavement you are having? Tell me. Yes. What are the stresses? There are different stresses you'll be having, right? Wheel load stresses. So exam టైం దగ్గరికి వచ్చినప్పుడు ఇంట్లో వర్క్స్ అసలు చేయాలనిపించదు, చేస్తే ఎనర్జీ లేదు. ఓకే రైట్. సో యూ హ్యావ్ టు మేనేజ్ బోత్ డెఫినెట్లీ. యా, యూ హ్యావ్ టు manage both definitely, right? Because you cannot escape from anything, is not right? So these are your wheel load stresses. And what are these? You can say these are your temperature stresses, if you just observe, right? So whenever it is your temperature stresses, na, what are these temperature stresses? You can say temperature stresses are this seasonal stresses, right? Those are also indirectly related to this temperature only, na? Seasonal stresses, right? What is the meaning of this seasonal stresses? Tell me. They are related to this seasons only, now. So that what is the first one? You can say warping stresses will be having or not? Warping stresses. So you are giving your experience to him. Okay. Okay. Yeah, Pavan, for that itself you are feeling like that. Then she has to do the all the works in the from morning to night, na? Isn't it? Entire work. Frictional stresses. The seasonal stresses will be which one? This is frictional stresses, isn't it? Yes, yes, correct. So you follow her suggestion, Pavan, okay? After getting government job only get married. Don't get married before that, right? Okay. So these are the different stresses we'll be having, right? Note this and tell me everyone. Note and tell me. Now, so what just see is 257th point. Nature of this stresses. So what is that we'll just observe, right? A nature of which one this wheel load stresses we'll see, right? Okay. They are saying you get married early. Okay, right. Yeah, very good, right? When you are listening to the classes now, na, automatically, right, what is it happening? You can say you can do whatever you want once you are getting your position. So here, this is your what? There are three different portions of a slab panel you are having. So this portion is your corner portion. Na? So now these are your corner portions if you just observe. What are these portions? You can say corner portions if you just observe, right? Isn't it? Now, what is this? You can say these are your edge portions. And what is that next one? Remaining all will be interior portion, na? Isn't it? So can we say these are the three different portions we are having, right? Edge, interior as well as this corner, isn't it? Edge, interior as well as this corner we are having, na? Isn't it? Now if you just consider, right, what is it you can say whenever it is that interior loading, right, what happens? That interior loading condition, right, whenever that wheel load is acting at the interior portion, right, what happens, tell me? It is behaving like which material? It is behaving like what? You apply the interior load, right? Load at this interior portion. Now, when you are applying the load at this interior portion, right, what happens if you just observe? Right, one second. So here it is behaving like which one? This is simply supported slab, na? No, no, no. Load at which one? This interior portion. That is what I am saying. Na? Three portions we have to consider, right? Load at this central portion. Central portion is nothing but your interior portion. Na? Central portion is nothing but your interior portion, right? These corners are there and edges, is not all. Simply supported slab behavior is there for this or not? Simply supported slab behavior is there for this, right? Whenever it is a simply supported slab behavior, right? What is it you can say? No, 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 Pawan, right? It is at the top, what is the nature of this stress, and at this bottom, what is the nature of this stress, you can say. At the top, what is the nature of this stress, and at this bottom, what is the nature of stress, you can say. At the top, it will be compression. Na? At the top, it will be compression. At the bottom, it will be which one? This is tension or not? Yes, at bottom, it will be tension, obviously, right? Now, second one, what is that you can say? Edge loading. Na? Whenever that wheel load is acting at which location? That edge location. that wheel load is acting at this edge location, right? What happens, you can say, how it will be behaving. So here this is your edge location, huh? The load, wheel load P is acting like this, right? What it will do if we just observe? So this is acting like which one? This is simply supported beam behavior, na? Simply supported beam behavior. Whenever it is a simply supported beam behavior also, what is the nature of stresses at this top and bottom? At this top and at this bottom, right? What is it you can say? Nature of stresses at this top and bottom, right? What is it you can say? Same, na? Top compression will come and bottom, what is it you can say? That tension will come into picture, na? Top compression will come and this bottom tension will come, you can say, yes, na? And what is the third one, you can say? Third one is what? What is it you can say? Corner loading, na? So whenever it is that a corner loading, right? How this corner loading? Okay, very good. If you are remembering, here if we just observe, whenever that wheel load is acting at this corner portion, na, how it will be bending? If you just consider, it will be bending like a cantilever beam, na, or cantilever slab. The behavior will be similar to that of your cantilever, right? Whenever it is similar to that of your cantilever, right? What is the nature of this stresses at this top and bottom? Tell me. At this top and at this bottom, what is the nature of this stresses at this top and bottom? If you just observe, at this top it will be tension, na? Top tension will be having, bottom, what is it you can say? Bottom compression will be having. Got it now? Is it clear? Is it clear of you? Right, done? Done every one of you? One student tell me, I'll try to close the session. Shall I close? Right. Okay, I'll be closing the session. Thank you all of you. Have a good day, right? Anyone having any doubts anywhere? Anyone having any doubts anywhere, all of you? In this? Any doubts, anyone? No doubts? Okay, if no doubts, I'll close the session, right? Thank you, tata, bye bye. Good night. Okay, yeah, good night for those who are going to sleep now. Okay, bye bye, good night. Okay.